Imagine spending 3, maybe 4 years of your life just tirelessly working to cure a disease.
Oh, that's a massive commitment.
Right. I mean, you collect all the data, you write up your groundbreaking findings, you submit it to this highly prestigious scientific journal, and 2 days later, it is thrown directly into the trash.
Ouch. Yeah.
And it's not because your science was bad, but simply because, you used the wrong citation font and your word count was too high.
It is a devastating scenario, but it's also one that plays out literally thousands of times a week in the academic publishing world.
Thousands. Wow.
Yeah. We all have this romanticized vision that truth just, naturally rises to the top completely unassisted. But the reality of the system is much more rigid.
It really is. Well, welcome to the deep dive. Today we are looking at a fascinating stack of notes and strategies from Dr. Arup Giri, and it's all about the absolute labyrinth that is academic publishing.
It really is a maze, yeah.
Our mission today is to completely demystify the journal submission process for you. We're pulling out a clear, actionable roadmap from the very first spark of study design, all the way to what happens after you finally get published.
And we should probably establish right up front, the lessons in these notes are not just for academics and lab coats.
No, absolutely not. Whether you are a researcher actively trying to get your work noticed, or maybe a professional who needs to pitch complex ideas to a skeptical board of directors,
Right.
or honestly just someone who is fascinated by how global scientific knowledge actually gets validated. This deep dive is for you. Because understanding how to bulletproof your ideas against intense institutional scrutiny, that's just a universal superpower.
Absolutely.
Yeah.
The sources we're looking at describe publishing as a passport to the global scientific community.
A passport. I like that.
Yeah. It validates hard work, and it can literally change how we understand the world. But, well, you have to get past the gatekeepers first.
Which brings us to that rather harsh reality check I mentioned at the top. Before we can talk about how to successfully publish an idea, we have to look at the mechanics of how and why ideas fail right out of the gate.
And they fail a lot. The statistics in Dr. Giri's notes are, frankly, staggering.
Yeah, they are.
At high-impact journals, anywhere from 30 to 50% of all submitted manuscripts face an immediate desk rejection.
Wait, up to half of the submissions.
Yes, that means they're rejected by an editor before they ever even reach a single peer reviewer.
Okay, let's unpack this, because to understand that massive number, the notes draw a really hard line between two types of rejections.
Right, technical rejections and editorial rejections.
Exactly. And the editorial rejections, those are the desk rejections.
And let's look at the speed of those desk rejections. They typically happen within 2 to 14 days of submission.
That is brutal. Someone spends years on a project and the door slams shut in under 2 weeks. Why does that even happen?
Well, the sources outline 4 entirely avoidable reasons. The number one reason, above everything else, is simply a poor fit with the journal's scope.
Which, I guess, is completely logical when you view it from the publication side of the desk, right?
Yeah.
Every journal has a highly specific mandate.
Exactly.
It's like submitting a brilliant, Oscar-worthy screenplay to a publisher who only prints cookbooks.
That's a great way to put it.
Yeah, it doesn't matter if your dialogue is transcendent and the character arcs are beautiful, they print recipes. If you send a script there, it is getting rejected instantly.
Right, it's just the wrong venue.
Huh.
But the other reasons for desk rejections are what really blow my mind.
Oh, me too. It's things like ignoring author guidelines, like literally just blowing past the word count or using the wrong citation style.
Or submitting incomplete ethics statements, like missing your institutional review board approval numbers.
Yes. And finally, just weak language and presentation that makes the manuscript too difficult for an editor to easily read. I mean, we are talking about some of the smartest thinkers in the world. How are they getting rejected for wrong fonts and missing forms?
It sounds absurd until you look at the sheer volume of information these publications are processing. Editors are just completely overwhelmed.
I can imagine.
They receive thousands upon thousands of submissions. So these non-technical mistakes, messing up the word count, missing an ethics statement, they serve as an incredibly easy objective filter.
Ah, so it's a heuristic.
Yes, exactly.
Yeah.
The harsh heuristic here is that if an author cannot follow basic, explicit submission guidelines, the editor assumes the underlying research might lack attention to detail as well.
Wow. So they just assume that if you are sloppy with your margins, you might be sloppy with your centrifuge.
That's it. It's a brutal filtering mechanism, but for an overwhelmed system, it's highly efficient.
Okay, so If getting past the editor is essentially just a test of your ability to follow instructions, the real crucible happens next, right?
Once you cross that initial border, we move into the second category, technical rejections.
And reviewers aren't looking at your formatting anymore. Now they are actively trying to poke holes in your science.
Yeah, technical rejections happen after the desk screening during the peer review process. This is where external experts evaluate the actual methodology.
And the sources point out something crucial here. Fundamental study design flaws are the leading cause of these technical rejections.
And the notes have a specific lesson here that is genuinely terrifying if you are in the wrong end of it.
Oh, the irreparable part.
Yes. They emphasize that study design flaws are completely irreparable after data collection is completed. It's stated as an absolute law.
But why is that? Like, why can't a smart statistician just massage the data afterward to fix a flaw?
Think about it like baking a cake. If you accidentally use salt instead of sugar in the batter and you put it in the oven and bake it,
Oh, gross.
right, you cannot magically extract the salt after the cake comes out. The fundamental chemistry of the cake is ruined.
That makes a lot of sense.
Yeah. It's the exact same with data. If you design a study without a proper control group or your sample size is mathematically meaningless, your data is fundamentally contaminated.
So no amount of fancy statistical math or beautiful writing can retroactively fix a broken experiment.
Exactly. Which is why the sources insist that the only way to avoid a technical rejection is to rewind the clock to before the research even begins.
And the note suggests starting with two foundational pre-research questions. Question 1, do you have a story to tell?
And question 2, is there an audience for your story?
Okay, I actually have to pause on that first one. Wait, aren't scientists just supposed to report the data? Why do they need to be storytellers? Isn't hard science supposed to be entirely objective?
Well, if we connect this to the bigger picture, data without context is essentially just noise.
Just noise. Okay.
Yeah, editors and peers aren't looking for a phone book of numbers. They are looking for original research that actually advances the field.
So it needs to shed new light on previous findings.
Or connect the dots between entirely different areas of study. A raw list of facts doesn't do that. A narrative that explains why those facts matter and how they change our understanding. That is the story.
Oh, I see. And regarding the audience, the idea is that your immediate peers will care if it contributes to their specific niche. But a broader audience is only going to engage if your research has clear, real-world implications.
Precisely. You have to know why your data matters before you collect a single data point.
Got it.
And once you have that narrative direction, you have to build the methodology. The notes are very specific about the pillars of a bulletproof design.
Right. Let's walk through those pillars because there is some dense terminology here.
Sure.
The first is formulating clear hypotheses to avoid being flagged for a weak research motive. The second is justifying your sample size using something called power analysis.
Right. Power analysis.
What exactly is power analysis for those of us who don't spend our days in a lab?
Well, apply the ELI 5 rule here. Explain it like I'm 5.
Please do.
If I were to prove a coin is rigged to always land on heads, and I flip it 3 times, and it lands on heads 3 times.
That doesn't really prove anything. It could just be a fluke.
Exactly. But if I flip it 10,000 times, and it lands on heads every single time, you believe me.
Yeah, I definitely believe you then.
So power analysis is essentially a mathematical formula used before the study begins to prove exactly how many test subjects or flips you need to ensure your results aren't just a random statistical fluke.
Okay, that makes total sense. Then the next pillar is establishing rigorous controls to avoid selection bias, which simply put just means making sure you aren't accidentally only testing people or things that already agree with your hypothesis, right? Like, I don't know, testing a new heart medication only on 20-year-old marathon runners.
Exactly. You'd be stacking the deck, whether intentionally or accidentally.
And finally, securing your ethical approvals early. Now, when it comes time to actually write all this down, the sources highly recommend using the IMRED structure.
Yes. That stands for Introduction, Methods, Results, and Discussion.
Or something called the STAR Methods Framework.
Right. STAR stands for Structured, Transparent, Accessible, and Reproducible. It is a specific formatting style that forces researchers to be incredibly granular.
How granular are we talking?
Well, the method section must be written in the past tense, describing exactly what you did, with enough detail that another researcher on the other side of the planet could replicate your work perfectly.
So it's basically a highly detailed recipe.
Exactly. Perfect replication is the absolute gold standard of valid methodology.
Okay, so let's say you have an unbreakable study design, you have a compelling story, your methodology is perfectly reproducible. How do you make sure you don't fall into that scope fit trap we talked about earlier? Where you send your brilliant screenplay to the cookbook publisher.
Well, you have to pick your target before you even finish building the bulletproof study.
Here's where it gets really interesting because that feels entirely counterintuitive. You are picking the venue before the product is even finished.
It sounds backward, I know. But this proactive targeting is exactly how top publishers like Elsevier and Wiley advise authors to operate.
Really?
Yeah. Think about the editorial desk rejections we discussed. If you wait until the manuscript is completely finished to pick a journal, you're going to waste months in the rejection cycle.
Because every single journal has its own unique guide for authors, right?
Exactly. Different formatting templates, specific scope limitations.
So by selecting the journal early, you tailor the length, the style, and the formatting exactly to their expectations from day one.
Right.
The notes actually provide a very specific 5-point pre-submission checklist to reverse engineer this process. Let's look at the mechanics of this checklist.
Good idea.
Point 1 is fit. They advise actively reading 3 to 5 recently published papers in your target journal to guarantee your topic, your methodology, and even your regional focus actually align with what they are currently printing.
This is critical. You aren't just guessing what they want. You are looking at what they just bought.
Makes sense. Point 2 is novelty. You need to be able to state your exact contribution clearly in 2 to 3 concise sentences, right in the introduction and the cover letter.
Which forces you to articulate your story quickly. If you can't summarize your breakthrough in 3 sentences, the editor certainly won't be able to figure it out while they are scanning thousands of submissions.
Good point. Point 3 is format matching word limits and reference formatting exactly.
Standard stuff, but
Yeah.
so important.
Yeah. Then point 4 is language. The sources actually suggest using professional editing services or language checkers if English isn't your first language.
Just to ensure your underlying science isn't obscured by the presentation.
Exactly. And finally, point 5 is ethics, explicitly disclosing all funding, conflicts of interest, and ethical approvals.
Right.
Honestly, this checklist applies to anyone listening who pitches ideas for a living. If you pitch a massive new marketing strategy to your CEO and you haven't tailored the presentation to the specific financial metrics they care about before you walk in the room, you're dead on arrival.
It is the exact same mechanism. If you follow that checklist, you practically eliminate the chance of a desk rejection.
Because you are giving the decision makers exactly what they asked for in the exact format they asked for it.
Precisely. Which means you survive the desk screening.
And now human reviewers enter the chat.
Yes, the peer review phase.
You've submitted this flawless study design, but peer review is where things get incredibly personal. This is the gauntlet. How you handle their critique basically determines your ultimate fate.
Peer review is the absolute cornerstone of validation in the scientific community. It is designed to stress test the work.
But receiving a laundry list of critiques on something you have poured 3 years of your life into can be, well, incredibly jarring.
Oh, I can only imagine.
You read these stories online about the dreaded reviewer too, this trope of the overly harsh, nitpicky reviewer who just wants to tear your work apart.
Yeah, reviewer 2 is famous.
Right. It must be so tempting to just fire back an angry email telling them they don't understand your brilliance. But the sources make a fascinating point here. The response letter you send back to the reviewers is just as important as the revised manuscript itself.
It is an exercise in extreme professional restraint.
Yeah.
There are golden rules for this response letter. First, you have to be impeccably polite, even if you fundamentally disagree with their assessment.
Fake it till you make it.
Pretty much. You have to thank the reviewers and editors for volunteering their time to read your work.
And the mechanics of the letter are strict. You must address every single point raised. You cannot conveniently skip the feedback you don't like or don't know how to answer.
Right, they will notice.
And you have to clearly differentiate their original comments from your responses, often using different colors or formatting and highlighting the exact changes you made.
Transparency is key.
And if you do disagree with a critique, you have to provide a polite, scholarly, and entirely evidence-based rebuttal, absolutely no emotion allowed.
Because politeness keeps the dialogue open, but evidence is what actually wins the argument. You are dealing with human beings. If you attack their intelligence, they will just dig their heels in.
Yeah, nobody likes being told they're wrong. But what if, despite your perfect study design and your incredibly polite response letter, you still get a rejection?
Well, the notes detail 4 realistic paths forward if you hit that wall.
Okay.
Path 1. Resubmit as is to a different journal, which you only do if the rejection was purely a scope or fit issue.
Makes sense.
Path 2. Fix the formatting or guideline errors and resubmit to the same journal, assuming they permit it.
Okay, what's 3?
Path 3. Substantively revise the study and collect more data, which is your only option if the reviewer has flagged a weak methodology.
And path 4?
Path 4. Appeal the decision.
Now, I want to zero in on this 4th option because, again, human nature makes us want to argue our case. When does an appeal actually work?
This raises an important question about the separation of one's ego from one's data. The source material has a very strict rule on this. Appeals, based on a disagreement with editorial judgment, rarely, if ever, succeed.
Wait, so you cannot appeal just because you think the reviewer's opinion of your data is wrong?
Correct. You can only appeal if you can prove a specific factual editorial error.
Really? Just factual errors?
So let me give you an example. If they rejected your paper stating that you failed to include a control group, but the control group data is clearly graphed on page 4, that is a factual error. They missed it. You can appeal that. I see.
Blunt.
But if you are arguing over whether your data implies causation or just correlation, that is interpretation. The editor's judgment on interpretation is final.
Wow, that is a tough pill to swallow, but I guess it makes sense. It keeps the system moving instead of bogging it down in endless philosophical debates.
Exactly.
So let's say you navigate the ego, you survive the crucible of peer review, and you finally get that magical acceptance letter. Your paper is published.
Time to celebrate.
Yes. But Dr. Giri's notes make a really crucial pivot here. As we shift to the final phase, the reality sets in. Getting published isn't the finish line. It is actually just the starting line for getting anyone to actually read what you wrote.
Because the sheer volume of science being produced is astronomical.
Yeah.
There are millions of research papers published globally every single year.
Millions.
Yeah, it is incredibly easy for brilliant paradigm-shifting work to just disappear into the void if no one knows it exists.
So the post-publication hustle is very real. Active promotion is literally required now. The notes detail some very specific mechanisms for this. First, you have to write a lay summary.
Right.
You have to translate your complex, highly technical findings into a short account written in clear, non-technical language.
Which is incredibly difficult for experts to do. It's the curse of knowledge. They forget what it's like not to understand the jargon.
Totally.
But the goal here is for the general public, and more importantly, science journalists and the media, to understand why your work actually matters. The lay summary is the hook for the wider world.
Then you have to harness social media. The sources mention using customized access options like share links.
Share links are a brilliant tool. Publishers provide authors with a specific link that grants 50 days of free, direct access to the article.
Oh, that's huge.
Yeah, you can post this on platforms like LinkedIn or directly tag relevant scientific societies and peers, getting it in front of the right eyes before it disappears behind a paywall.
And from a digital infrastructure standpoint, you have to keep your professional presence pristine, ensuring your SUPUSE profile, your institutional profile, and your ORCD are constantly updated.
Very important.
Now, ORCD is mentioned a lot. Can you clarify what that is?
Sure. ORCD stands for Open Researcher and Contributor ID. Think of it like a digital fingerprint or a social security number specifically for academics.
Ah, okay.
Because names can be common or change over time, and ORCD ensures that every single paper you publish is permanently tied to your specific digital identity.
So when someone does find your new work, they can click your ORCD and immediately see your entire career track record. And finally, you have to track your impact. The notes highlight that we aren't just counting traditional citations anymore.
Right.
We still use the H index, which is a traditional metric measuring how often your papers are cited by other scientists, but the sources emphasize modern metrics like Plumx metrics.
Plumx is fascinating because it monitors the digital footprint of the research.
How so?
It tracks social media shares, online captures like bookmarks, and mentions across news articles and blogs alongside those traditional academic citations.
So what does this all mean? It means modern scientists really have to be part marketer to succeed.
They really do.
It is honestly kind of wild to think that something as rigorous and deeply technical as a scientific paper is now being measured, at least in part, by social media shares and blog mentions.
It can feel jarring to traditionalists, certainly, but it validates a core truth about knowledge.
Which is?
The entire goal of science is for that knowledge to be understood and applied. If a breakthrough cure or a revolutionary new material is permanently hidden behind impenetrable jargon
All right.
or locked behind an expensive paywall where no one sees it, it isn't doing its job.
Yeah.
Measuring social media shares and lay summary reach isn't about vanity. It is about tracking how far the knowledge is actually traveling in the real world.
Wow. Well said. It is about making sure the work actually matters outside the walls of the lab. So let's wrap this up and summarize the journey we have been on today.
That's good.
We set out to demystify the submission process, and here's the roadmap we extracted from the sources. Success requires dodging those basic editorial formatting traps right out of the gate so you aren't part of that 50% desk rejection pile.
Essential.
It demands building an irreparable, bulletproof study design before you ever collect a single piece of data.
Right.
It means picking your target journal before you even finish the draft so you can perfectly tailor your submission.
Yes.
It requires surviving the ego-bruising gauntlet of peer review by relying on polite, entirely evidence-based responses.
Leave the ego at the door.
Exactly. And finally, it demands actively translating and promoting your work once it is out in the wild to ensure it doesn't get lost in the noise.
It is a phenomenal roadmap.
Yeah.
But looking at all of this, I want to leave you with a final thought to mull over.
All right. What is it?
We discussed how the source material strongly emphasizes that editors want research with a story to tell and clear real-world implications.
Right. The narrative aspect.
But it makes me wonder, if researchers are actively designing their studies specifically to tell a compelling narrative that pleases editors and secures publication, could we be inadvertently discouraging messy, inconclusive, or highly niche research?
Oh, wow.
Yeah, that kind of messy research might be just as scientifically valid, but simply because it doesn't fit into a neat, easily readable narrative, it gets left behind.
Yeah. Are we filtering out scientific truth just because it isn't entertaining enough for a journal's scope? That is a heavy, fascinating question to end on. Thank you so much for joining us on this deep dive today. We've gone from the very first spark of a research question to navigating the heavily guarded border crossing of academic publishing. Keep exploring, keep questioning the systems around you, and we will see you next time.